All right, so we're going to try and wrap up this lecture on the history of astronomy, the PowerPoint that I've made, and we just have left to go through classical modern astronomy, beginning with Nicholas Copernicus and the Copernican revolution. So let's get going here. Around the 1400s, over in Europe, we had a few revolutions going on. One was in thought and science with Nicholas Copernicus and his heliocentric view of the universe, which really contradicted what the church was teaching with the Ptolemaic system being geocentric. But again, the geocentric view of the Ptolemaic system was really starting to break down at this time. The observations weren't matching up with the predictions that the system had made, and so that's because that didn't have the motions correctly. The Ptolemaic system did a good job early on of predicting the motions of the planets, but as time went on, the differences in what was actually happening and what everybody thought was happening really started to become more pronounced. So eventually we had to kind of reevaluate the system, and that's when Nicholas Copernicus came out with his heliocentric theory. And the only thing that Nicholas Copernicus still had mistaken was that he kept the orbits of the planets circular, and instead they were actually elliptical. But we didn't get to know that until later on when Johannes Kepler did his work. So anyway, we're 1400s here, getting into 1500s. He was from Poland, and let's see some of the stuff that I have written here. So, of course, the revolutionary, and another big revolution that was happening at the time in Europe was with Martin Luther and the Protestant Reformation. And if you've ever heard that story, that's when Martin Luther went around to the churches in his town and nailed his thesis onto the church doors. It's a very famous event there, and that kind of kicked off the whole division between Catholicism and the Protestant religions. And then, you know, the ending story, a lot of the Protestants came over, the Quakers and early settlers came over with their religion to kind of conquer the early beginnings of North America and the whole Indian stories and all that stuff. So, but that's not for us today. So, again, challenged the Ptolemaic system, and he wrote, his book was On the Revolution of the Celestial Orbs, and he printed it at his death. You know, Copernicus was no dummy. He knew that the church would come after him if he started printing this heresy, because it went against what the church was teaching. So he waited until he was right on his deathbed to print the book, and he did get to see a final copy of his book before he died, and that way he could kind of bypass all of the persecution that he would have encountered had he published it early on in his life. So this was a complete overthrow of what was previously accepted, and of course alongside Martin Luther and the other revolutions that were taking place over in because the learning center had switched now from Greece, Rome, now it was in Europe with the Holy Roman Catholic Empire and everything like that through the Dark Ages. So we had the learning center, the world's culture center in Europe during this time, at least for the Western world. Kept the circular orbits, and that was a mistake again. But it was a better explanation of this retrograde motion that we can see in this diagram. So if we have the Earth orbiting the Sun, which would be down here, okay, Mars is on an orbit further out than Earth, and so Earth goes around a little bit quicker, goes around the Sun quicker. So we overtake Mars in our orbit at times. And as we pass Mars, kind of like two cars passing each other on the highway, the inside car on the inside lane, which would be Earth, sees Mars appear to drift backwards for a short time. That would be positions 2, 3, and 4. And so at position 1, we see it against, and we have the constellation Leo in the back here. So that's our reference point. So we see Mars at position 1 there. And then position 2, our line of sight puts Mars way over here in the constellation. Then 3, it starts to drift backwards because we are now catching up with Mars, and it's there. And so Ptolemy explained this using his little epicycles. Copernicus said, you know, this makes more sense if we just view the solar system like this. You know, this is how the Earth goes around the Sun and Mars is further out, and this makes perfect sense. That's why we'd see it drift backwards. So it's the apparent westward motion of the planets in the sky as the Earth overtakes some certain planets. Okay. Here's a picture of Copernicus with his model, and he's holding, I believe, a holly leaf, or it's some kind of special plant that kind of goes along with his ideas. It's a very famous type of portrait, and you can see Sol there would be the sun, and you have all the Latin names of the planets because the language of scholars back then was Latin. So... and I think that's all the pictures I have. And we go move on to Galileo Galilei. He would be known as the Defender a little bit after the Copernican revolution, but he supported heliocentrism, and his big deal was he actually provided some evidence for the heliocentric model of the universe through telescopic observations, and he did a lot of work on motions as well. So he built his own telescope and made lots of discoveries that gave really great evidence for the heliocentric view of the universe. Things like the lunar surface being imperfect and having craters when nobody thought that before, and they thought the moon was smooth. God's universe was supposed to be perfect, and here's Galileo saying, well, you know, the moon's got all these like apparent holes and stuff in it, and these big impact-looking structures. And I can see this with my little telescope here, and people don't want him saying that. Galileo encountered a lot of resistance from the church. He was persecuted, threatened to stop teaching what he was teaching and his discoveries. So Galileo had a really rough time, but he persisted in all of his evidences until, you know, the very end when he was on trial before the Spanish Inquisition and forced to recant his conclusions. So anyway, other discoveries, phases of Venus. That means Venus has to orbit its source of light if it's changing phases, if it's changing shape. And that again is evidence of a changing heaven. Again, this thought that the heavens, the sky is perfect and it doesn't change. Well, here's Galileo saying differently. The moons of Jupiter, this means that Earth wasn't the center of everything. If these moons were going around Jupiter, how could they go around Earth? Okay. Sunspots, another evidence for the imperfect heaven, and he discovered tons more stars than previously thought. Okay, so lots of evidences that supported the heliocentric theory. Or the Copernican view. He was very outspoken about it. He was adamant. He wanted people to know. They should know the truth, he thought. There's a great picture of Galileo, a portrait really, a painting. Pretty rough-looking guy in his old age. Big beard. Everybody had beards back then. He took on the man during the Inquisition. I say that because he stood up to the Catholic Church when they said, stop teaching. He said, you know what? I'm not. This is the truth. This is, you know, if people need to know this. He was interrogated a lot. He had to defend his ideas. He was threatened with torture. They said, you better not do this, or we're going to do what we did to your friend Bruno, who was a colleague of Galileo Galilei. They killed Bruno. They burned him at the stake in the middle of a town square in Rome to make a demonstration to the rest of the scientists or researchers or, you know, people who are coming out with claims like Galileo to say, you guys better stop this or this is what's going to happen to you. So unfortunately, during this time, there was a lot of persecution against people who were trying to just discover the truth and disseminate that information to the masses. So Giordano Bruno was burned at the stake in Rome. And this was also during the time period where anybody who had anything that couldn't be explained or do something like that was considered a witch. And they were, you know, those people, and a lot of them were just scientists working on new discoveries, okay? And the masses would say, well, we can't explain this, what you're doing, so you must be a witch. And so that's how it was. It was a hard time to be a scientist back in the 1600s. You all know the Salem witch trials story probably, and if you don't, you can look that up. Here's a portrait of him being interrogated by the Spanish Inquisition and standing up in front of them and kind of being very defiant. He was eventually forced to recount his ideas or recant his published works and admit his errors. So they said, listen, we're gonna kill you if you don't say that this is wrong and what you discovered is not right. So rather than dying, he chose to admit his errors, even though they weren't errors. And then the legend has it that while he was kneeling and kissing the Pope's ring, he whispered, "Y por si mueve," which means still it moves, talking about the Earth. Still the Earth moves. You know, he made wisdom, and that's we don't know if he really did that or not, and nobody probably knows, but it's a legend and it's kind of cool. He was put on house arrest for the rest of his life after that trial, which was the final trial that he had, and in 1990, 348 years later, the Catholic Church finally absolved Galileo Galilei, which means they pardoned and they said, you know what, we were wrong. This is obviously how it is. So he's officially off the hook now. You know, a victory for science, and a victory for all researchers out there, I guess, but a little late for poor Galileo. So that's kind of his story, and there's a lot of drama with that Galileo story. It's really neat to read about if you're interested. Tycho Brahe, the next one, he was a very famous observer, also a very, very weird person. He was a very proud nobleman. If you know what a nobleman was, that was somebody who was like, you know, high class, not royalty, but right below. He was extremely eccentric, had a lot of weird habits and suspicions. He wore this metal nose because he got his nose cut off in a duel over a math formula in college. You can put that in quotes, he kept a little person named Jep. That's a midget to the layman, if you know, that's a politically correct word, little person. So he kept a midget he kept it actually in a bird cage underneath the table. At dinner time, he would feed it fish heads, and Tycho thought that this little person had psychic powers, which is why he kept him around. He also had a pet moose or elk, we're not sure, different accounts, and this thing, I don't know, got loose and got into a cask of alcohol or beer and got drunk and apparently fell down the steps and died, and Tycho was very upset about this. So here's a famous portrait of Tycho Brahe. He's a looker, right? No, he's very ugly and hideous. And there's his moose in the background, or elk. One of the reasons he's depicted as kind of a ghostly figure like this, because his skin was probably very pale. He didn't sleep much. He was always up at night looking at the stars, and he made a lot of great observations. So he contributed a lot to the history of astronomy, but he nonetheless was a very odd character. He had his own castle observatory type thing on the island that he was given, and he was like the governor of that island. He was very mean to the common person. He was definitely involved in a lot of drama, adultery and murders, and you can read all about that if you want. But you can see no telescopes, just a lot of sight instruments in large celestial spheres, things of that nature, sundials and observatories. So he had his own island and an observatory there, and he made lots of observations for about 20 years. He accurately measured a lot of stellar positions and created star catalogs, things to that effect. His understudy was Johannes Kepler, who's a little bit younger than him. He was a great mathematician from Germany. He came to work with Tycho Brahe. He was a great analyst. Eventually, after Tycho Brahe died, and the story of Tycho Brahe's death is very odd. You can read that on your own, how Tycho Brahe died, if you're curious. But Johannes Kepler used all of Tycho Brahe's data, specifically on Mars, to figure out the laws and motions of the planets. And so he came up with 3 laws of planetary motion. He used the correct shape, which were elliptical shapes instead of circles. Here are the laws kind of stated out for you. Planets' orbits are elliptical. That's law 1, with the sun at one focus point. To make an ellipse, you have to have 2 focus points. One is the sun, the other is just a gravitational balance point called a Lagrange point. Law 2, a line from the sun to the planet sweeps out equal areas in equal time. That's this diagram right here. And then law 3, p squared equals a cubed, which means the orbital period squared in years equals the distance of the planet from the sun cubed in astronomical units, which is the average distance from the Earth to the Sun, or 93 million miles. Okay, Isaac Newton we are going to talk about a little bit, and I think I'm running out of time here for this lecture, so I'm going to pause this and we'll pick it up with Isaac Newton here, and I'll just wrap